This Interact educational resource builds on an Interact educational resource that describes the general dynamics of permafrost in the tundra, where warming is twice as fast as the global average. In this resource, we explore the specific case of how patterned ground and tundra polygons are formed. We describe a series of changes in the surface of the tundra that have occurred over decades or centuries or more. However, the development illustrated here can vary from place to place. Permafrost is any substance in the ground that remains frozen for 2 or more years. Large areas of tundra have patterned ground. Polygons are created when cracks appear in the ground surface due to very low temperatures in winter, particularly when there is little insulating snow cover. These cracks are caused by stresses in the drying and shrinking soil surface, and the resulting pattern is one of polygons, just like in drying mud at the bottom of a drying lake or riverbed. At the beginning of the process, cracks appear during winter in both the active layer, which is the upper summer thawing ground layer, and the permafrost. During the snow-free period, melting snow and surface water collect in the cracks and freeze. The ice in the permafrost remains frozen, even in summer, building up ice wedges. Cracks form in the ice wedges, and the process of freezing continues, and the ice wedges grow in size. The increase in volume caused by the expanding ice wedges causes a buckling or heaving of the ground on either side and parallel to them. This creates rims that encircle troughs that can fill with water. During a warming climate, the polygon centres drain or dry, ice wedges thaw from the top, and the troughs start to join. As the troughs start to join, the low-centred polygons drain and mounds start to appear. When the troughs are completely joined, a landscape of low mounds is formed. In areas of very rapid ice wedge melt, such as the New Siberian Islands, mounds that sometimes reach about 2 metre high remain. In the valleys, you can already find the Pleistocene landscape level with mammoth tusks, while the tops of the mounds, called Bergeracs in the Yakutsk language, are home to wolves, foxes, snowy owls and lemmings because they are relatively warm and dry. In the most extreme case, the degradation is happening so quickly that no vegetation can grow, and carbon captured over thousands of years is being released as gas through respiration of microbes, as particles blown away by wind in dry weather, and as particles washed downslope in rainy weather or in the thaw. The process of polygon formation can be as fast as 10 years in the Russian Arctic. However, it takes longer to produce Bergeracs. We acknowledge many helpful sources and contributors.